Very good afternoon and all. We have discussed here. So computer graphics is one of the main part of the discipline in the computer science. So now we discuss about the Brejenhami line algorithm. The Brejenhami was derived the algorithm for using the DDA, differential data analyzer, for using the computer graphics. The line algorithm fully focused for that the minimum approximate close points of the line. So first Brejenhami, what is the meaning of the Brejenhami line algorithm? It's nothing but is determine the points of n dimensional. We have a two dimensional, that is one dimensional or two dimensional, because the n dimensional is like a three dimensional, like for using the graphics. So the n dimensional raster that should be selected in the order of form a close approximation to a single or straight line between 2 points. Maybe I explained that is the graph, maybe you want the graph like. So it is a slope means the origin of the 0 for the origin point, like the slope of the line means we can, that's a straight line, but that a close approximate we cannot to take that the part of in this closely approximate lines. So we can derive the starting lines of the ending lines points between that the raster scan to using the graphics may be approximately selected for this closing line. So in the algorithm should be solved that the one of the closing parameter approximate closing points and take that the solution of this Brejenhami line. So we can start that the starting coordinate A is nothing but is the x1 comma y1, like it's a starting point like x1 and y1, and the ending point the B like an x2 and y2, that is the starting point. I mean here the A it's the B, x1 and y1, x2 and y2. So that the 2 point is important, that the between the 2 points and approximate closely straight points to be clear, draw the straight line view. So efficient this algorithm is only integer to add and sub, that means addition and subtraction, multiplication, only perform these operations using the Brejenhami line algorithm. That the procedure, we can start the procedure. So we can take the start coordinate x0 comma y0, here the start coordinate x0 and y0, because the origins there no. So n coordinate is xn and yn. We have the 3 steps to solve, or 3 main steps to solve in this algorithm. So the step 1 is calculate the delta x and delta y. The delta x and delta y, it is nothing but it is a slope of the algorithm. That slope means we can analyze for the delta and delta y from the DDA analyzer. DDA is nothing but data differential analyzer. So the DDA from taking the 2 parameter values, like one is a xn minus x0 and delta y is a yn minus y0. So these are the 2 main calculate values for the parameter in the step 1 from the DDA analyzer. And step 2, the calculate the decision parameter. The decision parameter, we can assume the value of the pk is a parameter of the value in the k. So it is used to what is the meaning of the decision parameter? Nothing but this is a x0 and y0 is a x2 and xn to yn, x1 y1, that means also. So calculate the true lines of the approximate pixel points of the value. We can find that the point the exact of the line. That means it used to find the exact line of the point in the draw line. So that's the only used for the decision parameter. The pk is nothing but we can calculate the formula of the pk. The pk is 2 delta x and minus delta y. That step 3 is. So next, if example we haven't take the starting point, that coordinate of the starting point. Suppose the current point is xk comma yk, means in the next point we can move the next slope or next line, that is the next point, approximate next point. So we can take the value of xk plus 1 comma yk plus 1 to find the next point depending on the value of the distance parameter in the pk. So we can calculate the value of xk comma yk. We can find the value of xk and yk, and then we can move that the next parameter of xk plus 1 and yk plus 1. We have some cases to find the solution in this algorithm. The first one is a case 1. Case 1 is nothing but we can, if take that pk is less than pk is the greater than of 0, means we can find this formula. Okay, the pk greater than 0 means less than 0 means we can take this formula. So next we can increase the step 3 means we can find the step 1 and step 2, and step 3 means we can find that the decision parameter current point. Maybe the current point is sk, and we can increase the point sk plus 1 equal to xk plus 1. In this case yk plus 1 equal to just yk only we can. Okay, next case 2. If pk greater than R0, maybe greater than or 0 means the formula is pk1 equal to pk plus 2 delta y minus delta x 2 delta x. The coordinate of next coordinate we can increase the value xk plus 1 equal to xk plus 1, yk plus 1 equal to yk plus 1. These are the two cases can be go to solve the algorithm of Brejenhami line algorithm. So, is 3 steps is a simple steps like on a step 1, step 2 and step 3. Step 1 we calculate the delta x, delta y. Step 2 we can take the decision parameter, and step 2 we can increase the next coordinate point. So, this is the only very simply understandable for the Brejenhami line. We can go to some examples. So, what are the advantages of this algorithm? So, this Brejenhami line is already available for the circle algorithm. So, we can now discuss about only the line algorithm. So, that is the algorithm from DD analyzer for the data differential analyzer. So, what are the advantages? Is avoid to generation of the duplicate of point. We have what meaning of duplicate means we have the some closing of features or some closing of approximate point is there, sum of differentially duplicate points is there, that the point is avoided for using this algorithm. So, the outcome is very important for this algorithm. And next, the implementation of using hardware. What is the hardware means we can take the number of hardware applications. That is a very efficient and algorithm for this one of the algorithm, and is also faster than only one thing of disadvantage in this algorithm, that means is only the basic of line drawing. So, only for focus the line drawing is only one of the disadvantage of in this algorithm. We can now to next because we need the case. So, cases we need, okay, some examples there now. So, I take the example value of example, I take the starting coordinate value and end coordinate value. I think the start coordinate is x naught comma y naught, end coordinate is xn and yn. So, here I take the value, starting coordinate value is starting coordinate value 9, 18, 14, 22. So, is a starting coordinate value. We can find that the pk. Pk is a parameter. So, first step we can find the delta x and delta y, delta x and delta y. So, delta x formula already we know that the formula of delta x, the delta is nothing but xn minus x naught, yn minus y naught. So, the formula is nothing but xn for calculate the decision parameter, calculate the delta of the slope, 14 minus 9 I think, 22 minus 18, 14 I think 5, 22 minus 18 I think 4. So, the decision parameter, the starting coordinate values of the delta x 5, delta y is 4. For next we can that the parameter value pk, we can calculate the pk. What is the formula of pk? Pk is nothing but pk equal to that the value of 2 delta y minus delta x. The pk is nothing but 2 delta y minus delta x. So, we can apply the value delta 2, delta y means 4 minus 5, again the pk is 3. So, we calculate the pk. So, we can know we have a pk parameter, decision parameter value. We can substitute the cases. What are the cases? We have 2 cases. That's 3 cases mean case 1 is pk less than 0, case 2 means pk greater than or equal to 0. The value is pk equal to 3. Maybe the case 2 is satisfied of this value. Case 2 is satisfied. So, we can formula for the pk1 equal to pk plus 2 delta y minus 2 delta x equal to the decision next coordinate values is x k plus 1 equal to x k plus 1, y k plus 1 equal to y k plus 1. Okay, we can apply the values for this. Pk is already know, pk is 3 plus 2 into delta y already know, we can delta y is 4 minus 2 delta x already know the 5 Okay, 3 plus 8 minus 10, so minus 2. So 3 minus 2 is a 1. So here the pk1, the next parameter value is pk1 is a 1. So we can table columns there. Table column. The table column is value for in the value pk, first one pk, okay, and second one is next coordinate values like pk1 plus 1 and next xk plus 1, yk plus 1. So what is the pk value? Pk value starting, the pk value is 0. So the pk value is starting 0, starting 3 means the starting coordinate, the starting coordinate values. What is the starting coordinate? 9, 18. There is a starting coordinate of values. 9, 18 is the starting coordinate. So we can calculate the parameter value is 3 pk. So pk plus 1 means that the value, what is the one? That 1. So what is the next coordinate? Next means we can find the value xk plus 1. What is the xk plus 1? Xk plus 1 equal to xk plus 1. Yk plus 1 equal to yk plus 1. Yk means yk values already we know 9 and sk plus 1, that is the one of 9, 9 plus 1, 18, 18 plus 1, 10, 19. So next parameter value is 10, 19. So 10 and 19. Next we can take the parameter pk1 is a 1. Again we calculate that's a value here. We can apply value for what is here pk. What is the pk? pk1 value is next parameter already here now. 1 plus 2 into delta y. Delta y means I think already is available. Delta y means 4 minus 2 into, so and next the one of the previous means the pk1 is, so pk equal to 1. What is the case is satisfied? Again the satisfied of the case 2. Again the same formula. So that is be here. So 2 into 2 multiplication of the value of 5. Again 1 minus same. What is the value of minus 2? 1 minus 2 equal to, again pk plus pk value 1, 2 into 2 of multiplication of delta y is 4 minus and 2 into 5 plus 8 minus 10, 8 minus 10 to minus 2 equal to minus 1. So the value of minus 1, we can take the minus 1. Already know the next parameter xk plus 1 equal to yk plus 1 equal to, what is the value of 10? 10 plus 1 is 11, 19 plus 1 is 20. So it's 11 and 20. So minus 1 here the pk1 value. The minus 1 is satisfied for this formula, maybe this formula, because pk less than 0. The pk value is minus 1. So again this formula is satisfied. Again the formula is changed. So we can substitute the value of this formula pk plus 2 delta y. Already know the pk 2 delta y and the next coordinate sk plus 1 equal to sk plus 1, yk plus 1, only yk. So the value of pk is pk we know the minus 1 plus 2 into, what is the value of delta y? The delta y is 4, 2 into 4. So minus 1 minus 8. So minus 1 plus 8 means equal to 7. The parameter of value is 7. So the pk value is pk1 is 7. So we can take 7. So next coordinate value equal to xk plus 1. Xk means 12. Yk same yk 20. Okay, 7. Take the pk variant is 7. 7 is nothing but it's a case 2 is satisfied. Here we can take same minus 2 delta x and here plus 1 also. So pk value is 7 plus 2 delta y, I think delta y is a value of 4 minus and 2 into delta y of 5. So 7 plus 8 minus 10. So actually 7 minus 2. 5. Again the value of 5. So again next coordinate values like but no 13 and 21. Again the 5 the distance parameter. 5 is satisfied for the case 2. So again they apply for the same value 5. Same case 2 formula 5. So 8 minus 10. Here 5 minus 2 3. Again the value of 3. Yeah, the value of 3, right? So again next coordinate we can increase the coordinate value xk plus 1 also yk plus 1 okay is a 14 and 22. Again we listen that the value of 14 22 because it is a starting coordinate value 9 18 and coordinate of end value so 14 22. We can reach that the coordinate of value of 14 22. The algorithm is fully satisfied. Maybe the Brejenhami line are fully satisfied. We can draw the slope. So we can draw the slope. Here I can erase this one off already know. We can draw the slope. So how the slope means we can take the distance parameter value y of x. So first value we can the origin. So again I can take the limiters like a 5, 10 or 15. 5, 10, 15, 20, 25. Here also I take the 5, 10, 15. 20 or 25. The exactly value means no. 9 xk plus 1 means it's a 9. I think it's a 9 here. 9 to 18. That means the value of year. And 50 and 10 to 19. The value of year. 11 to 20. 11 to 20 maybe the value of year. And 13 to 20. The 13 I think here no. 13 or 20 that value of year. I think 14 and 22. 14 I may be the 22 years. This is the law of the drawing. So this is successfully completed for the Brejenhami alignment. Thank you very much. Thank you for that.